Good morning, children. In this video, I will be discussing about volumetric analysis. It is a practical of class 12, that is a redox titration between KMnO4 and Mohr salt. I will be also completing KMnO4 versus oxalic acid in this video itself, because there is slight difference. So basic procedure I will explain, and how do you calculate. Procedure means how actually you're supposed to perform this titration in the lab. So if you know this, then you will be able to perform it well and calculate it, so you'll not be going wrong. So the question, suppose it's given like this: prepare 100 ml of M/20 Mohr salt solution, and using this solution you have to find the strength and molarity of given KMnO4 solution. Now, first thing is, it's not necessary always 100 ml, maybe 200 ml, 250 ml. Accordingly, volume you will change. Molarity, instead of M/20, if it is M/10, M/40, that also can be changed as per the molarity formula. So there are two steps in this experiment. So the first experiment is you need to prepare Mohr salt solution M/20. So we prepare the solution in a standard flask. Now, what is a standard flask? When you see in the lab, you will have, standard flask of this shape. It's not the conical flask, it has a long neck, and it is 100 ml we have to prepare, so we will use 100 ml standard flask. Here there will be a marking. So up till this level it is 100 ml. So we always prepare standard solutions in a standard flask. It is also called as volumetric flask. Standard flask because we have to prepare a known concentration solution. So what is a standard solution? This one, in which the standard solution is that of which we know the concentration. So we are preparing M/20 Mohr salt solution, 100 ml solution. So the first step for this is we will have to calculate the weight of the Mohr salt solution. So the formula for Mohr salt is FeSO4 dot ammonium sulfate dot 6 water molecules. This is the complete molecular formula of Mohr salt, and the molar mass is 392. So 392 is the molar mass. We have to prepare 100 ml M/20. So we will use molarity formula. Molarity is equal to weight by molecular weight into 1000 divided by volume in ml. So we know almost everything but for the weight. So we will substitute it. Molarity is 0.05. 1/20 we have to prepare. 1/20 is 0.05. It is equal to given weight. We have to calculate that weight. Molar mass is 392 for Mohr salt into 1000 divided by, we are preparing in 100 ml. So we'll substitute this as 100 ml. And when we calculate this W, this 0 will get cancelled. You can calculate this W. W comes out to be 1.96 gram. So this is the first step you have to do. You have to calculate the weight. How much weight has to be done? So you will weigh in the watch glass. You will take a watch glass and you will weigh 1.96 gram of Mohr salt in the watch glass. You can use electronic balance or the physical balance, whatever is available in your lab, and you will weigh 1.96. And then this has to be taken in the standard flask. So for that, what you do is you will keep here funnel. You have funnel in the lab. You will take funnel, and on this funnel you will pour this 1.96. So whatever we have taken here, this amount 1.96 grams Mohr salt we are pouring in it. So this we are pouring in it. Now when we are pouring this, the salt will be sticking here. Do not bother. Let it be here only. If some salt goes down, no issues. If little is sticking, don't add water right now. So what you do is, to this standard flask only, you will have to add half test tube half test tube dilute sulfuric acid. Half test tube dilute sulfuric acid is to be added to this. On the funnel itself you will add it. The purpose of adding dilute sulfuric acid is because the ferrous in Mohr salt undergoes hydrolysis. To prevent the hydrolysis of the ferrous salt, we add half test tube dilute sulfuric acid. We have added it. Now we add more distilled water to it plus distilled water. First you will add little quantity of distilled water to it and dissolve it. Dissolve it such that it gets dissolved. The Mohr salt is solid. It gets dissolved in the standard flask. And now you can go on adding dropwise water, distilled water to it till it comes to this level. Now this you can remove. Funnel you can remove when you are adding water, because if funnel is removed later on, little water may be sticking to this, or when you're removing it the level might change. Sometimes this neck is also long, it may be dipping into the solution. So you remove the funnel and now you can add distilled water to it dropwise such that the lower meniscus is touching this line. There is a line over here, till here it is 100 ml. So the lower meniscus of the water which you are adding, lower meniscus should be touching this marking. Why lower meniscus? Because this solution which you are preparing is a colorless solution. If the solution is colorless, the lower meniscus should be touching this line. And add water to it, and this is your M/20 Mohr salt solution prepared. So this is a standard solution prepared. So one work is done. You have prepared M/20 Mohr salt solution. Right? Now what you can do is you can take this Mohr salt which you have prepared in a beaker, because every time to remove from this standard flask will be difficult. What you do is you can remove this in a small beaker. You can take a beaker. In that beaker you can pour this Mohr salt solution. So in this now you have taken this Mohr salt solution. Right? Now let's move on to the next step. Yeah, this is now the second step we have to do. Second step is you take burette. This is burette. This burette you will have to rinse. You'll have to rinse means just adding little water to it, or whatever solutions we are rinsing, add little solution to it and just turn it like this, move it and throw it from the top. So that in the beginning you can throw it from the top, but otherwise after the solution is to be used for rinsing, it should be thrown from here. That means, say we are rinsing first with water. You can use rinsing with tap water first, then with distilled water. So when you are rinsing with water, say distilled water, you will add water from the top. You will close this top, cork, close it, and then just turn the burette like this so that even the inner walls are clean. They are having only water. Then just lift it like this and open this, and so that the water should come out through this, so that the nozzle part is also clean. It is also having only water. Then you have to rinse with the given KMnO4 solution, whose concentration we have to find out. Rinse with the given KMnO4 solution. So even this nozzle should be clean. While removing the solution from the nozzle, you can open this top cork. After that again you can close it. Fill KMnO4 in it. This is 50 ml capacity. Burette is of 50 ml capacity, and you can fill it. It is graduated from here, it is 0. So here there will be 0 marking. Fill it up till here such that upper meniscus is touching the line. That means this KMnO4 is violet color. It's a violet color. The upper meniscus should be touching that 0 marking. This is say 0 upper meniscus, because it's a colored solution. For colored solutions, upper meniscus should be touching the marking, and for colorless, as I said earlier, Mohr salt mein the lower meniscus should be touching. So fill it with the KMnO4. This whole thing will be having now KMnO4. Right? This was the second step we have done. Now we will move on to the third step. In the third step, we will take this pipette. This is pipette. Pipette, you will have to rinse it. You will have to rinse this pipette with water. Here there is a marking. We have taken 10 ml pipette. This pipette which we have taken is 10 ml. 10 ml pipette we have taken. You rinse it with water. Rinse this pipette with the given, the prepared, what we have prepared. Rinse with Mohr salt solution, which we prepared earlier. We took in that small beaker. You rinse this pipette with the Mohr salt solution. Okay. This was only KMnO4. Now you are rinsing this pipette with Mohr salt solution. This is the opening. So you will suck it from here. This Mohr salt. Take little here. Rinse it. Just turn the pipette like this. And again you can throw it from here. This forefinger you have to use to close the pipette. Okay. You will take it from this side and the solution will go in and close it from here to stop. And again to remove the solution you have to lift this finger up. So this solution will go down. Water first rinsing, then rinsing this with Mohr salt solution. Fill this till here. Again the upper meniscus should be touching, no, it's a clear solution. Lower should be touching this line. This is the marking. So lower should be touching till here. You fill it. And then you will have to take in a conical flask. This solution you have to take in a conical flask. Now before you take in the conical flask, you will have to take conical flask and you will have to rinse this conical flask also. You will have to rinse this conical flask only with water, nothing else. You will not be rinsing with the Mohr salt solution. Because if you rinse it, in the beginning itself with the Mohr salt, this will have little quantity of Mohr salt. So which will increase the volume of the Mohr salt. So you will rinse this conical flask only with water, distilled water. With distilled water. And then after you rinse it, just try to just turn it like this. No need to wash it and dry it and all that. Just rinse with distilled water. And now you pour this 10 ml Mohr salt into the conical flask. Whatever Mohr salt we have taken in the pipette, you pour it in the conical flask. And after this conical flask is there having Mohr salt, you can put that conical flask here. Below, you can take the conical flask, put it below KMnO4 solution. Below this burette. And you can open this top. Before that, you have added in this, what all things are there in this conical flask? There is 10 ml. There is 10 ml Mohr salt solution in it. Apart from that, you also add half test tube dilute sulfuric acid. Before titration, you'll have to add it. To the conical flask, you have rinsed with water. You have added 10 ml from here, Mohr salt into it. And then you also have to add half test tube dilute sulfuric acid. Purpose of again adding dilute sulfuric acid is to provide acidic medium. Because this KMnO4 will act as an indicator in the acidic medium. So you will add half test tube dilute sulfuric acid to it, and now you can place it below the burette, open the stopcock, dropwise. This KMnO4 should go inside. When you begin the titration, the solution here is clear, it is colorless. In the beginning here, in the conical flask, it is colorless. You go on adding KMnO4 to it, go on shaking this conical flask. Again add, again shake it, till you get pink color. Means you should get slight pale pink color in this. Pale pink means the end point is achieved. At end point, you will have this color change. From colorless, it will become pale pink. Once it is there, you are having pink, stop. Stop the titration. You can note down what is the reading from here. From 0, how much it has gone. How much KMnO4 has been used to convert this colorless to pale pink. Note down this reading. And then you can remove this conical flask. Wash it with tap water. This conical flask, wash with tap water. Rinse with distilled water. Again take 10 ml Mohr salt, half test tube dilute sulfuric acid and titrate again. So you will have to perform 1, 2, 3 readings. You'll have to perform this experiment 3 times. Till, not necessarily 3 times exactly, because till you get 2 consecutive readings the same, you will have to go on performing the titration. Every time when you note the reading, you can take this now as the initial and continue titration. You can take next one here and so on. Every time conical flask is to be rinsed only with tap water and distilled water. And every time you are taking 10 ml Mohr salt from here with the help of the pipette and half test tube dilute sulfuric acid. The pipette is not to be rinsed again and again. This rinsing KMnO4 and water was only in the beginning till it was, the inner surface was clean. Once you have rinsed, now every time you are not rinsing, every time you are using this pipette only to take out 10 ml Mohr salt from here and adding half test tube dilute sulfuric acid and performing the titration. So you can note down the reading now in your tabular column. Yes, and so you can have here initial reading, initial burette reading, final burette reading, and how much volume of KMnO4 is used. How much volume of KMnO4 is used. Say initial reading, a rough example I'm giving. Say initial was 0 and this final came out to be say 11. Right? And now your initial is 11. And now you are getting this as say 10. For example, this is 21. I was writing the difference. 21. Right? And now suppose your initial is 21 and your final becomes say 31. So this difference was 11, this was 10, this was 10. A rough example I am giving. So what are the two consecutive constant values? These two. So you will use this as the answer. You will not take mean of the KMnO4 volume used. Mean is never to be taken in chemistry. You will have to use the two readings which are constant. That value you will note down. This is your answer. So what is the volume of the KMnO4 used? This 10. So using this 10 now you have to calculate it. You will calculate the molarity and the strength. How will you calculate that? Let me explain. Now to calculate that we need the equation. This is the equation KMnO4. Mohr salt mein only ferrous is undergoing oxidation and Mn is undergoing reduction. Ammonium sulfate, that doesn't undergo any change. So we are having Fe. Mohr salt is undergoing oxidation, so Mohr salt is acting as a reducing agent, and KMnO4 is undergoing reduction, so KMnO4 is acting as an oxidizing agent. There is no external indicator used in this titration. KMnO4 is acting as a self indicator. So now we have to make use of this formula. M1V1 by N1 is equal to M2V2 by N2. This molarity formula we have to use for finding the unknown molarity. So let one particular set be for KMnO4 and the another one let us use for Mohr salt and calculate. So what was the molarity of KMnO4? We don't know. We have to calculate the molarity. What is the volume of the KMnO4? This is the burette reading. We got the answer as the constant value 10. What is this N1? Number of mole of KMnO4. In the equation it is 1 mole. So we'll write down 1. Molarity of Mohr salt, it was given in the question 0.05. 0.05 molarity was given in the question. You prepare 0.05 molar Mohr salt solution. Volume of Mohr salt 10 ml every time we are using with the help of the pipette. Pipette we have to use 10 ml. Divided by what is the number of moles of Mohr salt. In the balanced equation you are getting 5 for Mohr salt. So 5. You will solve this. Calculate this M1 value. This M1 is what? It is the molarity of the given KMnO4 solution. That was our question. Calculate the molarity. Whatever answer you get, this much molarity. This much molarity is the molarity of the given KMnO4 solution. And then one more thing you have to calculate in the question. You have to calculate the strength of the given KMnO4 solution. The strength of the given KMnO4 solution will be this molarity which you calculated multiplied by molecular weight of KMnO4. That is 158. So M1, what answer you get? Into 158, you will write down the answer as this much gram per liter. This is the answer. This much gram per liter. The strength of the given KMnO4 solution comes out to be this much gram per liter. Okay. Now suppose you are asked another question. This is second titration. I've written most of the things just to save time. Suppose the question is prepare 100 ml M/20 oxalic acid solution. Using this, find the molarity and strength of given KMnO4 solution. Most of the steps are same, but for only two differences, right? See, standard flask, Mohr salt, oxalic acid formula is H2C2O4.2H2O. 126 is the molar mass. We have to prepare 1/20. So we'll use molarity formula. 1/20 is 0.05. Given weight, 126 is the molar mass. We are preparing 100 ml. Standard flask we have used. So we'll use it. Calculate the weight. Now this weight we will use 0.63. You'll put a funnel over the standard flask. Put in this 0.63 grams of oxalic acid and add distilled water. Add distilled water to it. No addition of sulfuric acid. In Mohr salt, we were adding half test tube sulfuric acid also to prevent the hydrolysis of ferrous. Here we do not add because this will not undergo hydrolysis. So only 0.63 grams of oxalic acid plus distilled water. Fill it up till here. The lower meniscus should be touching the line. This is the first difference between Mohr salt and oxalic acid titration with KMnO4. Now you can take this and pour it in the beaker. Every time to take from the standard flask is difficult. Pour this, transfer this standard solution in the beaker. And now we move on to the second step. So now what happens in the second step, we are taking burette. Again, I have not drawn the burette, just I wrote burette here. So burette, you will be rinsing again the same manner, rinsing with water. You will rinse with the given KMnO4 solution. You will fill in this KMnO4 till that top 0 marking. And then this is the, clamp this burette to the burette stand, which we also did in that previous titration. Moving on to the third step, pipette has to be rinsed with water, has to be rinsed with the oxalic acid solution. What oxalic acid we prepared, 0.05 oxalic acid, you have to rinse with it and take 10 ml in the pipette and transfer it in the conical flask. You take the conical flask which is only rinsed with water. This is only rinsed with water. Pour 10 ml of oxalic acid which you have prepared in this, and then place this conical flask 10 ml containing this conical flask is containing 10 ml oxalic acid plus half test tube dilute sulfuric acid. This is to be added. This is same. This is not a difference. I will tell you the second difference. Before you place this conical flask below the burette, you have taken in there 10 ml oxalic, half test tube dilute sulfuric acid. You will have to heat this. Put it on the burner. On the tripod stand, you put it and you have to heat it till you get, some moisture getting accumulated here, till 1 or 2 bubbles start coming out. Reason, oxalic acid is a covalent compound. It's a covalent compound, so bonds will not break easily. So as to speed up the reaction, we have to heat it till 1 or 2 bubbles start coming out. Till 1 or 2 bubbles start coming out, you have to hold this conical flask with some cloth so that you don't hurt yourself. Place it below the burette. Perform the titration as you did in the previous. The color change is the same. Colorless to pale pink. Note down the reading as we did in the previous case. Initial reading, final reading, constant readings, which two values are constant. That reading you note down, and then we will have to use the calculation part. Okay, like I showed you in the previous one, you'll make an initial column, final column, note down the readings of the KMnO4. Readings might be different, but this is just I'm showing you once again. Okay, so constant value you will note down. So basically between KMnO4 Mohr salt and KMnO4 oxalic acid, there are two differences. One difference, while preparing a standard solution of Mohr salt, you add half test tube dilute sulfuric acid. In oxalic acid, you do not add. Second difference, while performing the titration here in oxalic acid, you are heating. In Mohr salt, you do not. Rest everything is same. Of course, equation will be different. In this again, KMnO4 is acting as oxidizing agent. Oxalic acid is acting as a reducing agent. This is itself undergoing oxidation to carbon dioxide and KMnO4 is undergoing reduction, and this is how you will calculate it. Using the same formula, M1V1 by N1 is equal to M2V2 by N2. Let one set be for KMnO4 and the another set be for oxalic acid. Mohr salt, KMnO4's molarity we have to calculate. So that is M1 multiplied by the volume. Let this also be 10. This is the constant burette reading which you get, because KMnO4 is taken in the burette. Number of moles what you have in the balanced equation against KMnO4, that is 2. Molarity of oxalic is given in the question. You prepared 0.05 molar oxalic acid. Volume in the pipette every time you are taking 10 ml. And the number of moles of oxalic acid in the balanced equation you are getting 5. You will solve this to get the molarity answer. This will be the molarity of the given KMnO4 solution. Then you are also asked to calculate the strength of the given KMnO4 solution, which will be molarity multiplied by molecular weight. Molecular weight here which we are using is always of KMnO4. So you will have M1, the molarity which we calculated here, multiplied by 158, that is the molarity of molecular weight of KMnO4, and what answer you get here, this much grams per liter you are going to write down. This is this much grams per liter. Okay, so before you go for the practicals, you should please complete go through the whole video properly, see how calculations I have explained, so that you don't go wrong in the exam. Okay, thank you.